All right, today we're going to go ahead and finish Unit 10. So if you could go ahead and hit pause and try this Unit 10.5 bell work on your own and see how you do. All right, so hopefully you took a moment to pause. If we're looking at numbers 1 through 5, it wants us to graph or solve each inequality and then graph the solution. So number 1, the first thing I'm going to do is I'm going to combine like terms. So I get 2 is less than or equal to x plus 6. I subtract 6 from both sides and I get negative 4 is less than or equal to x. So it means I do a closed dot at negative 4 and it's my smallest number, so it's everything to the right, so it looks like this. Number 2, if I'm looking and want to solve this guy, remember just because it has the 2 inequalities, it means when I do things to get q by itself in the middle, I just have to do it to both sides. Meaning when I want to get rid of 8, I'm going to subtract 8, but I'm going to do it from all 3 sides. So I do it from the middle, so it cancels. On the left, it becomes negative 12. And then on the right, it becomes negative 20. Then from here, I'm going to divide by negative 4. And when I divide by a negative, remember that flips the sign right here. So I get 3 is less than or equal to q, less than or equal to 5. Remember, since q is in the middle, that means I care about everything in between. So I do a closed dot at 3, closed dot at 5, and I care about all of the stuff in between. 3, I'm going to solve both of these. So I'm going to do this guy on the left first, meaning I'm going to subtract 2 from both sides to get 3w is less than 3. Divide both sides by 3 to get w is less than 1. On the right, I'm going to subtract 8 from both sides to get negative w is less than or equal to negative 6. Divide by negative 1, which means I'm going to flip my sign so I get w is greater than or equal to 6. Now, because it's or, that means that they're going opposite directions. So I have an open dot at 1, I have a closed dot at 6, and then it's everything on the outside. So w is everything bigger than 6 and everything less than 1, like so. 4, remember when we're looking at an absolute value, we want the absolute value by itself, which it is. And this is saying that a positive is greater than or equal to a negative, which this is always true. Thus, this means this is all real numbers. So if we wanted to graph that on a number line, that just means we'd have a line across the entire thing with arrows going in both directions, like so. Okay, 5, I can see that my absolute value is not by itself. So the first thing I need to do is I need to get rid of the 5. Remember, to get rid of that, I do not distribute, I divide. So I'm going to divide everything by 5 to get absolute value of 12 minus r is greater than 3. Then from here, I can split it up. So I keep everything the same on the left. So I go 12 minus r is greater than 3. Then on the other side, I still keep 12 minus r, but instead of greater than, I write less than. Instead of 3, I write negative 3, and from here I solve. So I subtract 12 from both sides to get negative r is greater than negative 9. Divide everything by negative 1, which means I flip this sign, so I get r is less than 9. Doing the same thing over here on the right, I'm going to move this guy just so I have room. I'm going to subtract the 12 from both sides to get negative r is less than negative 15. Divide by negative 1. Flip the sign so I get r is greater than 15. So if I'm looking at this right here, I can first of all see that I have 9 and 15. So I'm going to go 8, 9, 10, 11, 12, 13, 14, 15, 16, and 18. So I'm going to do an open dot at 9, and it's everything smaller, so I'm going to go to the left like this. Then r is greater than 15, so I do an open dot at 15, and it's everything to the right like this. And that's how you graph that absolute value one. All right, and then last couple things with 6 through 9, we want to graph the inequalities. So if I'm looking at this first guy right here, remember this means I start at 1 and have a slope of negative 1. So I'm going to start right here. I go down 1 and over 1. Because it's greater than or equal to, that means it's a solid dot. Or solid line, sorry. So it goes something like this. Now from here, I need to figure out which side I need to highlight. I'm going to go ahead and try the point 0, 0 and see what happens. So I have 0 is greater than or equal to 0 plus 1, which when simplified is saying 0 is greater than or equal to 1. That's false. So since it's false, I don't highlight the side with 0, 0. I highlight the side that doesn't have 0, 0, like that. Same thing with the next one, just this time I want to find my x and y intercept. So I do the cover-up method, so I cover up my y's to get negative 2x equals 6, and I cover up my x's to find my y, which is 3y equals 6. Dividing both sides by negative 2, I get x equals negative 3, and dividing both sides by 3, I get y equals 2, meaning I have a y-intercept at 2 and an x-intercept at negative 3. I can see that I just have a greater than symbol, not greater than or equal to, so that means it's a dashed or dotted line across like this. And now I'm going to go ahead and see which side I should highlight. So I'm going to again try the point 0, 0, which means I get negative 2 times 0 plus 3 times 0, and I want to know if that's greater than 6. Everything on the left simplifies to be 0, so that's saying 0 is greater than 6, which that's false. So it means I don't highlight the side with 0, 0. I highlight the other side, which is this guy right here. All right, and then last two, I have x is less than or equal to negative 1, meaning I would just draw a solid line where x would equal negative 1 like this. And then I need to figure out which side is x is less than negative 1, which is everything on the left, because I want smaller than that, so it goes just like this. And this last one, I draw a dotted line at negative 1 with the y because it's just a greater than, not a greater than or equal to, so it goes like this. Then from here, I want everything for y that's greater than 1, which means that's above the line right here. So I just highlight this side like that. Okay, and that's the 10.5 bell work. So hopefully you got that, and if you have any questions, feel free to let me know. But let's go ahead and go to the next page. So all we are doing today is we are taking linear equations and we're making them into systems. So remember that a system is a set of two or more linear inequalities with the same variables. So we've already talked about systems before, but they would just have equal signs. So all we've done is we've just changed the equal signs to inequalities. Now, when we do have the solutions of linear inequalities in two variables, it's the same thing as before, that we write it as an ordered pair. And now, the difference between this and systems in the past. Either systems in the past had one solution, infinitely many, or no solutions. In this case, they always typically have more than one. The reason for this is because when we graph them, remember we highlight the shaded area where that's all possible solutions that are true. So we can see, for example, on this example that's graphed right here, we can see that this line right here is highlighted everything to the left. We can then see where this dotted line is right here, it's everything to the right. There is this slim piece from right here to here, this little piece right here, where it is highlighted by both. That is the solution set to this system of inequalities. So it means we have infinitely many solutions in this region. So when it's asking you to pick a point, it's asking you to pick a point in that region, and that's what it's asking for. And we'll go over more of what that looks like in a minute. Okay, so let's go ahead and go to the next page and try this. So if we look at number 1, 1 through 4, I guess I should say, we want to tell whether the ordered pair is a solution of the system of inequalities or it's not a solution. So if I'm looking at this first one, I've been given the point 0, 0, so I'm going to plug it in. So for this first one, I just get 0 is greater than 2, which that's false. So that means that it's not a solution. Doing the same thing with number 2, I'm going to go ahead and plug this in. I have the point negative 1, 1. So if I plug in 1 for y, I get 1 is less than 3, which that's true. Then for my next one, I get 1 is greater than negative 1 minus 4, which that simplifies to be 1 is greater than negative 5, which is also true. So this is, yes, a solution. Number 3, We've got this guy. We're going to go ahead and take this point and plug it in. So taking the point 2, 3, I get 3 is greater than or equal to 2 plus 4, which is saying 3 is greater than or equal to 6, which that's not true. So that means this is not a solution. And last one, 4. If we're looking at this guy, I have the point 0, 4. We're going to plug it into here. So I have 4 is less than or equal to 0 plus 4, which simplifies to be 4 is less than or equal to 4, which is true. Then the next one I have 4 is greater than or equal to 5 times 0 minus 3. 5 times 0 minus 3 simplifies just to be negative 3. So I have 4 is greater than or equal to negative 3, which is also true. So that means yes, this is a solution. Okay. Now, when we are just given the graphs like we are in 5 through 8, what it wants us to do is it wants us to graph each of these inequalities, and then where they are highlighted over, it'll give, where both of them are highlighted in the same area, that'll give us a solution set, and then we want to find one point in that solution set. So if we're looking at this first one right here, we want to graph y is greater than negative 2, so I draw the horizontal line at negative 2, and it's everything bigger than that, so it's everything above like this, okay? Then for my next guy, I'm just going to do this because it's going to be easier. Sorry, just give me 1 second. Okay, and then for this next guy, we have y is less than 3x, so it means I start at 0, 0. My slope is 3, so I go up 3 over 1, and then it is a solid line because it has equals 2 underneath it, so it should look something like this. Now, I need to figure out what point would make this a true statement. I can't use 0, 0 because it's on the line, so if I try 1, 1, I get 1 is less than or equal to 3 times 1, which is saying 1 is less than or equal to 3, which is true, so that means I can highlight this side right here. So I can see the part that is orange and green is this part right here in this top right corner. So I can pick any point I want in this area. So I can pick the point 4, 3, and that's it, and you're done. As long as that is in the section that is highlighted by both inequalities, then you're good to go. So doing the same thing with number 6, we see in this case we have y is less than 3. So I'm going to draw a dotted line at 3. And it's everything underneath it like this because it's everything smaller than 3 for y. And then x is less than 2 means I have a dotted line at 2, like so. And when x is less than 2, that means it's everything on the left like this. So I can see that I have this area in this bottom left corner that has both the orange and the green. So I just pick any point that I want. So I'm going to pick negative 1, negative 2. And if you want to go ahead and pick a different point than me, that's fine. Just make sure it's in that shaded region that has both colors, okay? Now, 7, we can see this guy. Again, we know how to graph this. We're going to start at negative 2, and then my slope's 1, and I can see it is greater than or equal to, so it means it's a solid line. So I go up 1 and over 1, and I graph my line something like this, okay? When I'm looking for a highlighted region, I'm going to try the point 0, 0. So that means I get 0 is greater than or equal to 0 minus 2, which becomes 0 is greater than or equal to negative 2, which is true. So I can go ahead and highlight this top portion right there. Okay, and then for this next one, I'm going to start at 2, and then I have a slope of negative 1, meaning I go down 1 and over 1. I do see it's just less than and not less than or equal to. So it is a dashed line this time. It's not a solid line. So that's going to slightly change how I draw that. Then from here, I just need to pick another point and see what's true. So I'm going to try 0, 0 again. So I get 0 is less than 0 plus 2, which is saying 0 is less than 2, which is also, again, true. So when highlighting, I'm going to go ahead and I'm going to highlight this side where 0, 0 is placed on. And I can pick any point in the region that is shaded by both of these over here on the left. So I'm going to pick the point negative 3, 3. And you're done. And again, if you'd rather pick a different point, that is fine with me. All right, and the last one on this page, we're going to graph both of these. So if I look at the first one, I would do the cover-up method. So I would cover up my y's to be left with 2x equals 6, then cover up my x to be left with 3y equals 6, divide both sides by 2 or 3 respectively. So I get x equals, not 6, x equals 3, and then I would get y equals 2. So I'm going to go ahead and draw my line at 3 and 2 between those x and y intercepts. I do see that it's just less than, so it is a dotted line. So I draw my dotted line so it looks something like this, okay? Now from here, I want to pick any point, so I'm going to try the point 0, 0. If I do that, I get 2 times 0 plus 3 times 0 is less than 6. Which everything on the left simplifies to be 0 is less than 6, which is true. So that means I can go ahead and highlight the side that contains 0, 0. And then for this last part, I'm going to go ahead. I don't know how to graph this, but I can solve it for y to be able to graph it. So I have y minus 1 is greater than or equal to negative 2x. I can add the 1 to both sides to get 1 is greater than or equal to negative 2x plus 1. So I start at 1, and then I go down 2 and to the right 1. Because it's got the equals, it's greater than and equal to. It means it's a solid line, so it looks something like that. Now from here again, I'm just going to pick any point. I'm going to pick the point 0, 0. So I have 0 is greater than or equal to negative 2 times 0 plus 1, which is saying 0 is greater than or equal to 1, which that's false. So since that's false, I pick the side that does not contain 0, 0, which is this guy over here. So now when I'm looking for a point, I look for any point in this shaded region right here that has both of my solution sets. So I'm going to pick 3, negative 2. And that's how you solve systems of inequalities when we are given the inequalities and we want to graph them. Now, we are going to do the reverse. So if we go to the next page, we see in 9 through 14, we were given the system of equations drawn out on graphs, and we want to write it down as inequalities. So if I'm looking at this, I want to take this one piece at a time. So I'm going to start with the line that goes straight up and down, or that vertical line, and I can see that it's everything highlighted to the left. So if we were just looking like that, from the past, we would say, okay, I know this is x, I know it's not equal to because it's dashed, and I know that it's everything less than negative 2. And the reason I know that is because it's everything that's on this left-hand side right here. Now I do the same thing with the horizontal line that's going straight this way. I know this means it's y. Again, it's dashed, so I know it's not equals to. It's at 3, and I can see that y is everything below that, meaning it's everything smaller, so I'd go y is less than 3. And that's all you have to do, and that's your system of equations. Okay, so doing the same thing with number 10, we can see that we've got this dashed line right here, and it's everything above it in this direction. So I'm going to do y, it's my smallest number, so I'd do is greater than 1. And now I'm going to do the same thing, but it's with this horizontal line, and it's everything below. So I would say y is less than 3. And that's your system of inequalities, and you're done. Now, what happens when we have them so they're not horizontal and they're not vertical? This is what we're going to do. So first, let's do this line that I just highlighted green right here, okay? So the first thing we want to do is we're going to go y, and then remember we're going to do box because we don't know what goes there. We know that for the line, my slope is 1, so that just means I have x, and I started at 1, so it's plus 1. My two options are greater than or equal to or less than or equal to. When I look at this guy, my highlighted region is this over here, so I'm just going to pick a point. So I'm going to pick the point negative 1, 1 right here. This means I would have 1, I don't know what goes right here, and then I have negative 1 plus 1, which that simplifies to be 0, so I have 1 box 0. If I want this to be true, the one I'm going to pick is greater than or equal to, so that's what goes right there is greater than or equal to. Now doing the same thing with this other dashed line right here. If I'm looking at this guy, I start with y and then I put a box. From here, I can see that my slope is -1 because I go down 1 into the right one. So that means I have negative x and I start at 1, so that goes +1. I have two options. I have greater than or I have less than as an option. I'm going to pick any number in this highlighted section over here on the left, so I'm going to pick the point 0, 0. So I have 0, box, and then that would be 0 plus 1, which means I would have 0, box, 1, which for this to be true, I would have to say 0 is less than 1. So that's what I pick right here, meaning my system is y is greater than or equal to x plus 1, and y is less than negative x plus 1, like that. Okay, and then if we're looking at this next guy over here at number 12, I can see that this first highlighted line right here, I can do that guy first. So what I'm going to go ahead and do is I can see that it's y. I don't know my sign yet, but I know that it starts at -2 and it has a slope of -1. So I have negative x minus 2. My two options again are less than or greater than, and I can see that it's everything highlighted on this side right here, so it includes the point 0, 0. So if I try 0, 0, I get 0, box, and then 0 minus -2 is just -2, which means 0 is greater than -2, so that's what I put in my box up above. Doing the same thing now with this other line right here, I have y, box, and then I'm going to start at 1 this time, but I still have a slope of -1, so I have negative x plus 1. And I can see that it's everything down here below. So again, it includes the point 0, 0. It's dashed, so it's either less than or greater than. So I have 0, box, 0 plus 1 is 1. So for this to be true, I need to say 0 is less than 1, so that's what goes in my box. Meaning my system is y is greater than negative x minus 2. And y is less than negative x plus 1, like that. All right, and then these last two. 13, when it looks just like this means that this is my highlighted region where both of them were true. So I can do the exact same thing that I was doing before. So I'm going to start with my dashed line right here. I can see that I have a slope of -1, and it goes through -1 for my y-intercept. So I'm going to have y, box, negative x minus 1. Because it's dashed, it's either greater than or it's less than. Picking any point that I want that's in this highlighted region, I'm going to pick -1, 4. So that means I get 4, box. Because it's a negative x, that means -1 turns into 1 minus 1, which means I have 4, box, 0. Which means 4 is greater than 0, so that's what goes up here. Doing the same thing with the second line in this system, I've got y, box. I can see that it starts at 4 and has a slope of 1, so I have x plus 4. Again, I just need to pick a point in the highlighted region, so I'm going to stick with -1, 4. So I get 4, box, -1 plus 4, which is 4, box, 3. I forgot to write, it's either greater than or equal to or less than or equal to. So I would write 4 is greater than or equal to -3. So that's what I write, is I write y is greater than negative x minus 1, and y is greater than or equal to x plus 4. And this last one with 14, I can see with this guy that I've got two dotted lines, so I know for both of them it's either going to be less than or greater than. I'm going to go ahead and I'm going to do this guy first. This guy I can see starts at -1 and has a slope. It goes down 1 over 3. So I'm going to do y, box, and then I'm going to do, there is not a ton of room over here. I'm going to write this on the bottom. Sorry. So I'm going to go y, box, -1/3 x minus 1. Pick any point in the highlighted region, and again, remember it's either less than or greater than for both of these, so I can see 0, 0 is true. So I'm going to go 0, box, and then -1/3 times 0 is 0, minus 1 is -1, so that means 0 is greater than -1, so that's what goes right here. Then for this last one, we're going to do this line right here where you can see it starts at 3 and it goes up 2 over 1, so it means it's a slope of 2. So I have y box 2x plus 3, and from here, again, I'm going to plug in the point 0, 0, so I get 0 box 2 times 0, 0 plus 3 is 3, so that means 0 is less than 3, so that's what goes right here. Meaning that for my system, I have y is less than 2x plus 3, and I have y is greater than negative 1/3 x minus 1. Okay? And that's how you can solve systems of inequalities with graphing. Go ahead and get started on your homework quiz. If you have any questions, feel free to let me know.